Hey guys, welcome to your next tutorial. In this tutorial we're going to be making our first particle engine. It's going to render simple 2D particles and we're going to do so in a cache-friendly way. Hopefully you watched the previous tutorial. Now, one thing about the cache friendliness and polymorphism is it's going to be really hard to do polymorphism here, and we probably we're just not going to do it for this. We will be able to define custom behaviors for the particles, but we have to do so in a different ways. Today we're just going to work on a basic particle that has no custom behavior, and then the next tutorial we will work on actually adding the ability to define particles that do different things. Now, the reason I say that is because here's sort of an example I had from the previous video where I made an A star my array, and then I allocated an array of B in a cache-friendly way. So we could imagine A is like particle or something like that, and then B is like moving particle. There's an example that makes sense. So if we wanted to make an array of moving particles like this, this would allocate the memory for it polymorphically, but when we go to iterate it, if we were going like for int I equals 0, I is less than 1,000, I plus plus, and we wanted to iterate my array, it's actually, since we're not iterating pointers here and we're iterating instances of a particle, because remember this is an array of particles, not an array of moving particles, then we're actually going to get bugs here if moving particle and particle are not the same size. Let's say particle is 1 byte in length, so we have like char A, and we'll make that public. And moving particle is 2 bytes because it has char B. And remember, it also gets A, so it has A and B in here since it's inheriting from particle. That means moving particle is going to be 2 bytes, particle is going to be 1 byte. So whenever we call new moving particle here, it's actually going to allocate 2,000 bytes because we're making 2,000 moving particles. However, since we're using polymorphism here, whenever we iterate the array, we're iterating an array of type particle. So if I say I here, this is actually going to be iterating 1 byte at a time, not 2 bytes at a time. This is the only problem with trying to do polymorphism in a cache-friendly way. Now, if we had a vector of pointers instead, like I showed you with the vector in the previous tutorial, the inefficient way to do it, that would work just fine because we don't have an array and we're not iterating an array of contiguous memory, so the size of these don't matter. But for now, just don't worry about that. I wanted to go ahead and preface this video by talking about that. If you are a little confused by it, don't worry about it. I'll show you the right way to do things. So let's go ahead and create our particle engine. We're going to go to Engine, and we'll go ahead and click Add, Class, Add, and ParticleEngine2D. Alright, so now we have the ParticleEngine2D. This is going to be part of Engine, so let's go ahead and do namespace Engine, or whatever your game engine is called. And we'll do the same thing in the CPP file. You could also, I don't know if I've showed you this, but you don't have to wrap everything in the CPP file. You could also say Benjin : before everything. That'll work too, but I just don't like having to do Benjin : after everything. So sometimes it's easier to just do this. Your choice. Alright, so what does our particle engine need to do? Well, it needs to be able to render different batches of particles. Now, each particle batch will be basically a batch of particles that all have the same texture. So that we can efficiently render things. We'll basically just have different batches for different types of particles. Maybe all of our flame particles will be in one batch. All of our water particles will be in another batch. We could just use a single batch for everything, and that's totally fine, but it would be a little easier to manage for us probably to separate them into different batches. It all depends on what you want to do. So I'm going to do it this way, and if you decide you only want to use one batch for all your particles, that is perfectly fine. So let's go ahead and go to Engine. We're going to add a new class. We're going to add another class called a ParticleBatch2D. ParticleBatch2D. Alright. So we have ParticleBatch2D here. Let's go ahead and put its little Engine namespace wrapper in. Namespace Engine, as always, because this is part of our game engine. And we'll do the same thing in the CPP file one last time. Alright, now, we need a particle class, and we're going to put that in, we'll put it in ParticleBatch. So we're going to say class particle. We could make a whole new file for this, but there's no need to. Particle is going to be pretty small. And it's going to have some variables and some methods. So what does each particle need? Well, it needs a position, so we're going to do glm vec2 position, and we'll need to include glm for this. Oops. is it GL/GLM or just GLM? GLM, that's it, GLM/GLM.hpp, so that we get that vec2 here. So we have a vec2 for position. Let's see, we could do a color if we wanted each particle in the batch to have a different color, or we could just give a global color to the entire batch. That's another thing we have to decide. So for now, let's go ahead and just do a color per particle. Now, one thing you should know is the smaller your particle class is, the more cache friendly this is going to be. Because remember, whenever we read something from the cache, we're going to read probably about 64 bytes. If your particles are really small, then you're going to be reading more particles from your array in that cache at a single time. So you want to keep them as small as possible. So we have color RGBA8 color. And this file is in vertex.h, so let's go ahead and include vertex.h. There we go. All right, color RGBA color, position, what else? We need a lifetime, and this actually, color RGBA is undefined. What did I do wrong here? This is part of Engine, so it needs the single quotes, or the quotation marks. Engine, no. Vertex.h, there we go. Alright, so we need a lifetime for each particle. We don't want particles to exist forever. Instead, they should decay over time, and eventually they should go away. And I'm going to follow the naming convention m underscore for all of our private variables. So for the lifetime, we'll just use a float. So we'll say float m underscore life. And let's go ahead and do another float. Let's actually do a global float for the decay. So these are the things that are going to be different per particle. Now, the batch itself can have more properties, and these are going to be properties that are global for that entire batch. So everything in that particle batch is going to have these properties. This is why we have different particle batches, so we can have some global properties for each type of particle. So one thing we can have is a decay rate. Decay rate. And that's going to be how fast these particles disappear. We're going to start each particle out with 1.0 for the life. For the color, we won't worry about that. For the position, let's go ahead and start it out with glmvec2 0 just to be safe. It's always nice to initialize your variables to something. For the decay rate here, we'll just set it to 0.1 or something like that. Alright, and we also need, let's see, we need actual pointer to some particle data. Now, what we could do is we could do it as a static array of particles. We could say particle myParticles. And we could say 10,000. So what we're trying to do here is we're trying to keep all of our particles in a contiguous memory buffer, so it's nice and cache efficient. So what we can do is make a big buffer of particles like this, say 10,000 particles. That'll be the maximum number of particles we can have. And then we just iterate through this whenever we want to update particles and render particles. Now, what we should do here is we should have a bool is active. Like that, equals false. So right now, all of these particles are going to start out as inactive particles. So this is active bool is going to be false. So when we iterate this big batch of particles, we're not going to update any of them. We're not going to draw any of them. Whenever we call add particles, however, so we should make an add particles function. Add particle. We'll just do add particle, a single particle for now. Whenever we call add particle, it's going to find a particle in this array that is not active, and it's going to initialize it and set it to active. And then we'll be updating and drawing that particle until its life reaches 0, which will be decreased by the decay rate. And once its life reaches 0, we can get rid of that particle. And that's as simple as setting this imActive equals false again. Now, the reason we're doing it this way is because we want to not be calling new and delete all the time. We just want to have a big buffer of particle memory that we are constantly reusing. This is how you make a very efficient particle engine. So instead of doing it this way, I'm going to make it so that we can have a variable-sized particle batch. So we're going to initialize this to null pointer, and we're going to make it a dynamic array, null pointer. And to do that, we're going to have a, we'll say int m max particles, and this should be actually m my particles is a bad name. We're going to say m particles. And we'll say start out at 0, that's fine. And whenever we initialize the particle batch, we should pass in the number of particles we want. So I'm going to use the constructor to initialize particle batches. or actually let's use an init function. I like init functions personally. So we'll say void init, and we're going to pass in the number of particles. So int max particles. This is the maximum number of particles that this batch can handle. And then whenever we want to add a particle, we're going to need to pass in a few things. We're going to need to pass in a position. So we'll say const glm vec2 ampersand position. We're going to do a color. So color RGB, we'll say const color RGBA8 ampersand color. And for now, that's all we'll need, but we actually also want these particles to be moving, so let's add a velocity vector, glm vec2 velocity. Start that off at 0, glm vec2 0. Should actually be 0.0f because these are floats. Alright. And so we'll pass in velocity as well here, const glm vec2 velocity. Alright, so each time we want to add a particle to our engine, we just call this and it should handle that. So let's go ahead and write the init function first. So I'm going to copy both of these into the CPP file. And they both belong to ParticleBatch2D. We will be making a ParticleBatch3D in the future. That'll probably be in a different series. I think this series is going to be mainly just 2D stuff. Alright, and there we go. And you'll notice I didn't put all of these on the same line. I'm trying to keep the lines smaller. It's better that way, so you can have two code windows open and things like that. Alright, so we'll start with the init. Now, max particles needs to get set here, so we're going to say m max particles equals max particles. And now we need to actually allocate the memory for our particles using this m particles variable right here. So we'll say m particles equals new particle max particles. So that's going to allocate us an array on the heap. And now we want to make sure that whenever our particle batch is destroyed, we free that memory. You always want to make sure you have a delete when you ever have a new. So we'll call delete, and I'm pretty sure I showed this to you, but whenever you're deleting an array that you allocated with the square brackets, you have to say delete square brackets. Otherwise, it won't call the constructors or the destructors on all of your elements of that array. So we're going to call delete m particles in the destructor. There we go. Now, we should also be passing in the decay rate. That's probably a good thing to pass in for the init. So we'll pass in float decay rate. There we go. And I will copy that into the init function here. And we're going to say m decay rate equals decay rate. Alright, so that's init. Let's go ahead and write an update function as well. We do need to be able to update the particles. And we need a draw function so that we can draw all the particles. Copy both of those into the ParticleBatch2D. Most of the meat of this is actually going to be in ParticleBatch. The ParticleEngine class doesn't have a whole lot. It mainly just manages our particle batches. Okay, so the update function is going to just loop through all of our particles and update them. So we're going to say for int I equals 0, I is less than max particles, I++. Now, one thing we can actually do to optimize this is we were using this bool m is active here to determine if a particle is allowed to be updated, but instead an even better way to do it to save a whole byte is to get rid of this and just start out life at 0. And the way we know a particle is active is if its life is greater than 0. If its life is equal to 0, that would be as if the isActive bool was true, was false. So what we can do here is it's actually m underscore max particles. Is whenever we're looping through the particle list, we first need to check if it's an active particle, because if it's not an active particle, we don't need to update it. So we're going to say if m particles I arrow or dot what is it, m life. So let's go ahead and write a let's go ahead and make it a friend class. We'll say friend class particle here, because the particle batch should be able to touch all of particles privates. All right, and let's go ahead and do, obviously we need to make sure update and draw belong to ParticleBatch2D. All right, so if m particles I dot m life is greater than 0.0f. If this is true, so check if it is active. If this is true, then we're going to update the particles. So we're going to call mParticlesI.update. What's the problem here? It's inaccessible because I got my thing backwards here. It's actually friend class ParticleBatch2D. There we go. Alright, so we want to call an update function that we haven't made yet. So let's go ahead and give particle an update function. We will say void update, very simple function here, and we'll copy it into the CPP file up here at the top. And let's actually call this particle2D. Doesn't make sense to call it particle. So we'll replace particle star here with particle2D because we are going to have 3D particles as well. So we'll say particle2D update here. This is the last thing that needs to be changed to particle2D. And in here, we're just going to do something very simple. We're going to reduce the life by the... Actually, we're just going to move the position here and the velocity. Our particle is actually really, really simple. We're just going to say m position plus equals m velocity. That's right. We are making very basic particles in this tutorial. We will be making some more advanced particles later. All right, so that is the update function. Now we could also pass in the decay rate and have it decay itself, but it's easier to just do it here. We'll just say mParticlesI.life mlife minus equals mDecay rate. And that will make sure that every time we update it, it decays a little bit. So if the decay rate is 0.1, it's only going to last 10 frames. Now, because of that, we probably want to make sure that we are doing frame rate independent decay. So just like in our bullet functions when we passed in the float delta time here, we're going to do the same thing in ParticleBatch for our update function. We're going to say float delta time here. We'll do the same up here in Particle2D, float delta time, because remember, it is important that your simulation be frame rate independent. Make sure to change that in the CPP file. And now, instead of just plus equals m velocity, we're going to say plus equals m velocity times delta time. Put delta time there. And instead of minus equals decay rate, we're going to say minus equals decay rate times delta time. All right, and this will update all of our particles. But now we need to be able to actually draw and add particles. And after we have that, our particle batch little simulation thing is good to go once we just hook it up with our particle engine. So for drawing, we're going to want a SpriteBatch. We're going to use a SpriteBatch to render all of these. So let's go ahead and include SpriteBatch, SpriteBatch.h, and we will do a SpriteBatch, and we'll pass that in for drawing. And we will go ahead and, since all of our particles are going to be the same size, and they're going to use the same texture, now you may not want to do that. You may want to have them all be different. That's your choice. But for our basic particles, we're just going to make them all the same for each batch. Because of that, I'm just going to not make a draw function in the Particle2D class. Instead, the particle batch is going to handle all the drawing. It's going to draw all the particles. So we're going to go into the update function, or below the update function, to the draw function. And we need to make sure we, put SpriteBatch there. And now we need to loop through all our particles again and draw all of the active ones. So we're going to copy just this part right here, just like in the update loop. And if it is active, we're going to render it. Simple as that. So to do that, we're going to need to call SpriteBatch.draw. And now we need a destination rectangle. So there's a few things we are missing from our ParticleBatch2D. We need a particle size. So we're going to say, got an email. We're going to say float. We'll make sure all the particles are squares, so we're just going to assume that. We're going to say float width equals 0.0. And let's see, we need a texture, so we'll say texture 2D texture. I believe that's, is that, or is it just texture? Let's see, include texture, GL texture, that's what it was called. We'll include GL texture here. And we will put a GL texture down here. And let's see, what else do we need? We have texture, we have color. Let's see, I think that's it. And actually, just to give ourselves a little wiggle room with our particles, make them a little bit better, let's scratch that and let's go ahead and give the width to the individual particle. We will still make sure all of them have the same texture, but we'll be able to vary the size of each particle because it gives us a little bit better usage with that. So that means we need to add a few more things into here. We need to pass in the texture. So we'll say GL texture texture, and to prevent name conflicts, this should be m_texture here. So let's copy this into the CPP file. Here we go, init here, and then m texture equals texture. There we go. And all right, now we can draw it. So for the destination rectangle, it's going to be a vec4. So let's go ahead and create our vec4 here. We'll say glm vec4 dest_rect, and it's going to get initialized with the x and y, and then the width and height. And the x and y are the particles in position, x and y. So we'll say m particles I, and to avoid saying m particles I all the time, let's just do this. Let's do auto ampersand p equals m particles I. To make our code a little smaller, we're just grabbing a reference. So now we can refer to the current particle with just this p handle right here. So we'll say p.mPosition. My visual assist likes to put an arrow there. It should not be an arrow. .x, p.mPosition.y, and then p.mWidth, and p.mWidth again, since they are square particles. All right, so that is the destination rectangle. We'll put that here, dest_rect. Now we need a UV rect, and we are going to, for now, since we're not using any texture atlas or anything like that, we're just going to assume that the UV is 0 to 1 always. It's just the same UV rect. So we're going to say glm vec4 UV rect. If you are planning on using a sprite sheet, you will need to change this, of course. We'll say 0.0, 0.0, 1.0, 1.0. All right, and we'll pass in the UV rect as the second parameter. The third parameter is the texture, which is just mTexture.id. Now the depth is, we're going to say just 0. And for the color, we'll say p.mColor. All right, and that will draw the particle. So now we have the draw method, and it should work just fine. Finally, we need the method for adding a particle. So to do that, what we need to do is find the first particle that is not in use and set that particle to be active, and then set these three parameters for that. Actually, add particle should also take a width, because remember, we do want variable sized particles. So we'll say float width here. All right, so in order to determine what the first inactive particle is, and to make it really easy to look for the next free particle, what we're going to do is have a variable int last we'll say last free particle, like that, and we'll set it equal to 0. And what we're going to do is, since this is an array, we can't do any fancy lookups. We have to do a linear search, and now a linear search through an array is really slow. However, if we keep track of the last position where a free particle was, then most of the time we're only going to have to iterate one time. We're only going to have to go to the next particle, and it'll probably be free. And if all of the particles are not free, then we're in trouble, but that typically won't happen, depending on how big your max particles is. So let's go ahead and utilize this. We're going to need to make a method, and we'll say int find free particle. So this will find a particle that is not in use, and let's implement this in the CPP file. There we go. And we'll do that right down here. Belongs to ParticleBatch2D. All right, so what we are going to do is we are going to first loop through for int I equals last free particle. So we're going to start wherever the last free particle was, and we're going to assume that that's probably where the free particle is going to be. We'll say I is less than m max particles. I++. And this is just going to loop through that, and we're going to say if mParticles I dot life is equal to 0.0f, or is less than or equal to 0.0f, then we're going to say, all right, this was the last free particle. So we're going to say m last free particle equals I, and we will say return I. And that's going to return the index of the free particle. And that's pretty much it for the first part of this, but we also need to make sure that we wrap back around. So say we have 100 particles and last free particle is 50. Well, with this loop, we're only going to loop from 51 to 100. So we also need to loop from 0 to 50. So what we're going to do is make another identical for loop, except we're going to start I at 0, and we're going to go until I is equal to last free particle, like that. And then finally here at the bottom, we will just return 0. So if we get here, that means no particles are free. So no particles are free. So overwrite first particle. We'll just always overwrite the first one. May not be the best thing to do, but that's what we're going to do. All right, so that looks like that's going to work just fine. Now let's go ahead and utilize it. So first we're going to say int particle index equals find free particle. So this is the particle we are going to use. And now we are going to, let's go ahead and use this auto p thing here to grab a handle to that particle. Except instead of particles I, it's going to be particles particle index. And now we can initialize all its variables and things. So we'll say p dot m life equals 1.0f. We'll always start life out at 1. P dot m position equals position. P dot m velocity equals velocity. P dot m color equals color. And P dot m width equals width. All right, so that's how you add a particle. Really simple. And I believe our particle batch is finished, so now we can utilize it. Nothing going on in the constructor here. All right, so we need to have a way to actually register each particle batch with the particle engine. So we're going to say void add particle batch, and we're just going to pass in each particle batch that we want the particle engine to manage. So we're going to say ParticleBatch2D star batch. So we'll pass them in as pointers. We'll just say particle batch. And let's include particle batch. Actually, let's do just a forward declaration here. Class ParticleBatch2D, and we'll include it in the CPP file. So that will add a batch, and we also need a void update to update all the batches, and we need a void draw to draw all of the batches. And for the draw function, we will pass in a SpriteBatch, unless we want ParticleEngine to own its own SpriteBatch, but I think it would be best to pass it in. That way we can decide exactly what SpriteBatch it uses. So we'll pass in a SpriteBatch. We'll do a forward declaration for that too. SpriteBatch. It's always better to do forward declarations rather than to have includes up here because it makes your compile times a little bit better. So we'll say SpriteBatch star SpriteBatch. So let's see, we have add particle batch, update, draw, and let's store all the particle batches that we add. We'll just store them in a vector. We'll just say std vector ParticleBatch2D m batches. That'll be all of our particle batches. So what we're going to do is whenever we want to add, we need to include vector up here. Whenever we want to add a particle batch, we'll just allocate a new one, vector, and we will pass it in. And then from then on, the particle engine is going to manage that batch, including the deallocation of it, I suppose. So what we should do is, in the destructor, make sure we clean up all the batches. All right, so now let's implement all three of these. We'll copy these to the CPP file. And we'll have ParticleEngine2D there, ParticleEngine2D there, and there. We are almost done, guys, don't worry. All right. All right, so for draw, all we're going to do is we'll say SpriteBatch.begin And then we're going to call SpriteBatch.end and SpriteBatch.renderBatch, your batch. And we're going to put this inside a for loop that's looping through all of our batches, and we'll render each batch one at a time. So we'll say for int I equals 0, I is less than, let's actually use for each. So for auto, we'll say b for batch inside m batches. Got to use that C++11 syntax. And here we're going to say m batches, or we'll say b dot draw. And we pass in SpriteBatch. Now, we're getting errors here because we need to include the files up here. We only did 4 declarations, so we can't use them until we include the files. So we're going to include ParticleBatch, and we are also going to include SpriteBatch. There we go. And what's the issue here? Right. In order to forward declare these, since they belong to Bingen, we need to make sure we forward declare them inside Bingen, like that. Otherwise it won't work correctly. And that should work. Oh. Oops. This should be a pointer to a SpriteBatch. That is my bad. So make sure you change in the ParticleBatch2D.draw function, change it to a pointer to SpriteBatch, like that, and do it in the header file as well, pointer to SpriteBatch. Alright, so this will draw all of our batches, really simple. Now in the update function, it's even easier. We're just going to say for auto b inside m batches. We're just going to say we're just going to say b.update. And we need to pass in a delta time. That's one thing I always forget. So float delta time. Put that there. Do it in the CPP file as well. And we'll pass delta time right here. Okay, so we have update and draw. Let's do add particle batch. So we will say m batches.pushback with particle batch. As you can see, our particle engine is so simple, you almost don't even need it, but we are implementing it anyways, just to give ourselves a nice little manager class. And for the destructor, let's make sure we delete all the particle batches. Now, we're going to be allocating the particle batches somewhere else, so we need to make sure that we don't try to delete these twice. So we'll put ourselves a little comment here. After adding a particle batch, the ParticleEngine2D becomes responsible for deallocation. That'll keep us from trying to delete the particle batch in our main code, because the particle engine is going to handle that. So for auto b in m batches, delete m batches, or sorry, delete b, and then finally m batches.clear, but we don't actually need that since this is on the destructor. We're not going to use it anymore beyond that point. All right, so now let's go ahead and make use of it and see if it actually works. Hopefully it will. Let's go into our let's do some little blood effects. Let's go into our main game, which is in zombie game down here. Go into maingame.cpp and maingame.h. And let's get a ParticleBatchManager here, which is a particle engine. So we'll say Bingen ParticleEngine2D. And we will call it m particle engine. And to do that, we need to include Bingen particle engine up here. Particle engine. And let's also include the ParticleBatch2D as well. ParticleEngine2D and ParticleBatch2D. Now, what particle batches are we going to need? Well, let's have a particle batch for blood for now. We'll say Bingen ParticleBatch2D, and we will say star m blood particle batch. Okay, and let's go ahead and allocate that in main game when we initialize our systems. So let's do that down here. Initialize particles. So we'll say blood particle batch equals new ParticleBatch2D, and let's go ahead and register it to the particle engine. So we'll say ParticleEngine dot add particle batch, and we will add blood particle batch to be tracked and updated and drawn and all that. Now here in the constructor, we're having an issue. Oh, because it needs to be new engine particle batch. There we go. And let's go ahead and call init as well. So blood particle batch init. And the max particles, let's say we don't want more than 1,000 blood particles. That's quite a few. For the decay rate, let's say 0.01f. And for the texture, let's do... oh, right. I made a texture, actually. So I added a texture. You'll see in textures, I added a... Oh, this is somebody else's code I was looking at. Let's see. Visual Studio, projects, graphics tutorials, zombie game, textures. So I added this particle.png texture here in the textures folder. So let's see, what was our resource manager called? That's right, we are using a static resource manager. It's hard for me to remember all of the things we're doing when I'm constantly jumping between all these different projects. So we have this Bingen resource manager get texture, and I believe we need to include resource manager up here. I'm going to switch that to be non-static in a future tutorial, because it should not be static. Manager.h. That should work. There we go. There we go. So the texture we are going to get is textures / what is it, lowercase particle.png, yes. There we go. So that will initialize the texture that we want to use. And is there another parameter? No, that's it. Alright, so now we have a blood particle batch, and we can just begin adding blood particles whenever anything gets shot. But we need to make sure we're updating our particle engine. So let's go ahead and in the game loop, let's see, we will update the particle engine right here. We'll say ParticleEngine.update. And in draw game, we want to actually draw the particle engine. So let's go to draw game, and we will draw it after the agents. So the blood will be on top of the agents, but before the HUD, so the HUD renders on top of that. Render the particles. And we're going to say ParticleEngine.draw, and let's just reuse the agent SpriteBatch. So we'll say address of agent SpriteBatch, so we don't have to make a brand new SpriteBatch. And when you reuse the same SpriteBatch, you're going to reuse the memory buffer that it was using, so it actually will probably be a little more efficient if you can reuse the same SpriteBatch. Alright, so now we are drawing and updating our particle engine. All we have to do now is just add particles whenever anything gets shot. So anytime a bullet is removed, whenever it collides with a zombie or a human, then what we're going to do is just, spurt some blood out. So here's our check for whenever we do a collision with an agent for zombies. And then here's a check for collision with humans. So let's just add a function for adding a bunch of blood particles. We'll put it in the main game. So we'll say void add blood. And let's do a position. So we'll say glm vec2, say const glm vec2 ampersand position, and int num particles. That'll determine how many particles we want. Alright, that sounds about good. This adds blood, obviously, the particle engine. And let's implement that below draw HUD. Here we go at the bottom. Alright, now anytime we want to add some blood, we're just going to call this function, and it'll take care of it for us. So we'll call blood particle batch, add particle, and we're going to add it at position. For velocity, let's go ahead and do a random velocity. So we'll say glm vec2 velocity And let's initialize it to, what we should do is we'll initialize it to where it's going straight up in the air, and then we will rotate it using GLM rotate using a random direction. So for the velocity, we'll say 1.0 seems a bit high. We'll say 0.01f and 0.0f. And that'll be the initial velocity. And then for each particle, we're just going to randomly rotate it. So let's go ahead and give ourselves a random engine. So static MT, we need to include random up here. Oh, we are including random. 19937 for our random engine. This is much better than the default random engine. Rand engine, and we'll pass in time null pointer for our randomness, and this is actually std mt19937, and we need a distribution, so we're going to say static, we'll say uniform real distribution of float, and we'll say rand angle. And this will be anything between 0.0f and what do we want? We'll say 2 pi. I believe this is in radians. So for 2 pi, we'll say 2 times, do we have m pi perhaps? We do. You should have m pi, I believe it's defined in SDL. If you don't have m pi here, then you can define your own pi to be 3.141592 something. You can Google it. All right, so we're going to generate a, what is this? It's not a template. Oh, I'm missing std, of course. There we go. All right, that will generate us a random angle between 0 and 2 pi. And we're just going to call glm rotate. We will rotate velocity by, let's see, by rand angle, rand engine. And that will give us a random rotation. And in order to actually get this function to work properly, we need to include one more thing up here. We need to include glm rotate vector.hpp. Otherwise, it won't let us rotate it. Okay, and then we'll just pass in vel here. Or does glm rotate return a vector? Yes, it does. So we actually put glm rotate in here, and that will pass the rotated vector on. And we need a color. Let's just give ourselves a red color. So color RGBA8 call, and we'll initialize that to 255.0.0.255. It'll be a nice blood color, and this is actually benzene color RGBA8 call, and finally the width. Let's do 5. No, we'll do 10. They'll be pretty big. All right, and now we just need to, for int I equals 0, I is less than num particles, we need to add 1 particle for each of num particles. All right, and I++, of course. All right, now let's go ahead and utilize the add blood function to add a bunch of blood whenever bullets hit stuff. So here we go. If zombie collided with agent, yep, we'll add blood first. We'll say m zombies j dot position, get position. Is that what we want? Yes, we'll pass that in. So we're going to say add blood with m zombies j, get position, and we'll add 5 particles for each bullet. That should do it. Expression must have class type, so this should be an arrow. And we will do the same thing. What the heck am I doing? Arrow, get position. And we'll do the same thing with players, or sorry, with humans. There we go. If it collided with human, then we'll do m humans, j, get position. Or actually, it makes more sense to use the position of the bullet, doesn't it? That actually makes a lot more sense, because the blood should be coming from where the bullet is. So let's do that instead. We don't have a function for that. What do you know? So let's add, I'm in bullet.h here. let's add a getPosition function. We'll say glm vec2 getPosition const return position. There we go, and now we can say bullets I dot or arrow getPosition here. That's much easier. What's going on here? Oh, this one is a dot, of course. All right, we'll copy that up here. All right, moment of truth. Let's see what happens. So we're gonna hit play. We should theoretically get 5 blood particles every time we shoot something with a bullet, and we'll see if that works. It's a good chance it won't, because we wrote a lot of code. Oh, we got build errors. Too few arguments in function call. Ah, we need to pass in delta time. And this should definitely be happening inside of our logic loop here. What am I doing? Right here, after update bullets, we'll update the particle engine with delta time. There we go. Now let's run again. And it's building, and it's building. All right. Well, we can see blood there. The particles are very, very tiny. Let's increase the size a little bit. So when we go to add blood, at the bottom here, let's add blood with size 40. And for velocity, let's increase to 0.1. Now let's see what happens. Should be 10 times faster, 4 times bigger. Still going a bit too slow. So let's change velocity to 1. We'll go 10 times faster. And let's make sure we are getting random rotation, because it didn't look like it was randomly rotating. Looks like it's always going to the right. So let's see what's going on here. So the issue is the rotation, GLM rotate expects degrees, not radians. So we're going to do 0 to 360 degrees. And let's now increase the speed a little bit more. I want it to be faster. Let's do 2.0. Let's decrease the size to 30. And finally, let's actually make them decay a bit faster, because they're decaying pretty slow. Let's decay at a rate that is 5 times faster than before. And now we'll run, and we'll see some pretty shoddy blood effects. There's a lot of work that could be done. But as you can see, we have some primitive blood stuff now. Let's go shoot some zombies. Sorry, people. You're in my way. Woo! Infinite ammo is great. Our zombies are too tough! Oh god. Yeah, zombies have way too much health, and they've had way too much health for a while, so I'm gonna make this a little easier. Anyways, thank you for watching, guys. It has been really awesome. This was a pretty long tutorial. Hopefully you learned a lot. I'm surprised it worked the first time. Well, it kind of worked anyways. But yeah, these are really basic particles. Right now, they just move in one direction and then disappear. We can make them even better by making it so that instead of just moving in one direction and disappear, they slowly fade out. Maybe their velocity slows down. Maybe they persist for a long time and kind of stain the floor with blood, whatever. These are really efficient particles, so you should be able to have, you know, even 1,000 of them with no issue, probably even more. But in the future tutorials, we'll figure out how to add custom effects to our blood, and maybe we'll make like a flamethrower or something cool like that. Alright, thanks for watching, guys. See you later.